Today's lesson is going to be on the isosceles and equilateral triangles. So first, the isosceles triangle. There's multiple parts we need to label. The first is the two congruent sides. Remember, your isosceles triangle has two congruent sides. Those are going to be called legs. So that's these two sides right here. I know they're congruent because they put tick marks on them. So these are the legs of my isosceles triangle. And where those two legs intersect, here says sides, but the legs. That angle is called your vertex angle. So where my two legs intersect is right here at angle B. So angle B is going to be your vertex angle. The side opposite the vertex angle, so opposite means across from. So if I go across from that, that's going to be my base. Across from the vertex angle of your base. And then the two angles sitting on the base are called base angles. Makes sense because they're sitting on the base. Alright, so for an isosceles triangle, if two sides of a triangle are congruent, so if your triangle is isosceles, then the angles opposite those sides are congruent as well. So if I know that my two legs are congruent, AB and BC, then I can say that angle A and angle C are congruent as well. So if your legs are congruent, then your base angles are congruent as well. And just like in parallel lines, I can have the converse, which just means I can flip the order. So this one says if two angles of a triangle are congruent, if your base angles are congruent, then the sides opposite those angles are congruent. So then your legs are congruent. So again, if you have two congruent A, two congruent legs, that means you have two congruent base angles. And if you have two congruent base angles, that means you have two congruent legs. You can go in either order with your isosceles triangles. So to start that out, I know I have an isosceles triangle because I see two tick marks on my triangle telling me that these two are congruent. These are going to be your base angles because they're across from your congruent sides, which means that if J or L is 68, J has to be 68 as well. I have all my angles inside of a triangle but one. Inside of my triangle is 80. So if I subtract those 268 away, I'm going to get 44 here for angle K. On 2, it's a little different. I have my two congruent sides. So we have our two congruent sides, so we know it's isosceles, but we have the vertex angle this time, not 106, instead of our base angles. We know the ones across from it are going to be congruent, so C and E. But we're going to have to take our full triangle, 180 minus 106, and that gives me what's left for my other two angles. So my C and E can be 74. And I know they're both congruent, so I'm going to want to cut that in half. Give me 37 for it. And then on on number 3, we have two congruent angles, 77 and 77, which means our sides across from them are also congruent. So if xy is 12, yz has to be 12 as well. And then to find angle y, I can do 180 minus my 77 minus my 77, get 26. Alright. I'm not going to take the time to solve all these. I want to respect your time, but since I have two congruent sides, that means I have two congruent angles. So I can just set those two angles equal to each other. Again, since I have two congruent sides, I have two congruent angles. So I can set those two angles equal to each other. You have to make sure that you have the angles across from your sides. You have to have your base angles. The base angles sit along the same side. If you had your vertex angle, then you wouldn't be able to set equal. On this one, we have two congruent angles, which means the sides across from it, the legs are congruent as well. So across and across. And again, we have two congruent angles, our base angles, so across from it and across from it are going to be congruent. So we would just be setting equations equal to each other on all of these. But if we turn to page 10, these ones I don't have a picture. Picture is crucial. So just draw a basic triangle, it doesn't matter what it looks like, and label it R, S, and T. This tells me that RT is congruent to ST, which means my base angles, if I go across from RT, I land at angle S. If I go across from ST, I land at angle R. So my angle R and my angle S have to be congruent. So 9x plus 2 has to equal 13x minus 8. And again, this is because since ST is equal to RT, then angle S is going to equal angle R. Alright, so I'm going to minus my 9x first. Minus my 9x first. 2 equals 4x minus 18. Add 18. Add 18. 20 equals 4x. So that's that. We're on 4. So x is equal to 5. And then for all of these, we have to just plug them into the angles. So angle R is 9 times 5, 45 plus 2, 47. S should be equal to it. If you want to check it, plug it in and make sure that it actually gives you the same answer. And if it doesn't, then you know it's something wrong. Then angle T, 17 times 5 plus 1 equals 6. Alright, again, we don't have a picture, so we need to draw one. D, E, and F. This time it tells us angle D is equal to angle E. Well, follow across from it. Across from E is DF. Across from D is EF. So again, since angle D is equal to angle E, that tells me that side F is going to be equal to side EF. That's what that's telling me. EF and DF. Make sure you're taking the right ones. Those have to be equal. And then move my 4x. Add your 35 over. And then divide by 3. So x is 9. Again, plug in them in. Alright, so DE is equal to 9 plus 4, 13. EF is equal to 4 times 9, 36, minus 8, which is 28. And again, you can just say that DF is going to be that, or you can check it and plug it in. And making sure that you actually get 28. Alright, you go ahead and take your try at number 10. So pause the video and try number 10, and then enter in your answers when you are asked. Okay, now we are on to equilateral triangles. An equilateral triangle, you might have noticed this when we did the first section of this note, but every time you wrote equilateral, you also wrote equiangular. So it is important to note that if a triangle is equiangular, it's also going to be equilateral, and vice versa. So in this case, it's saying if A, B, and C are all equal, then AB is going to be equal to BC, and that's going to be equal to AC. So all my sides are equal. Every single one of my angles are equal. Every single one of my sides are equal. So again, if my sides are equal, then my angles are equal. So equilateral means equiangular. So in this first one, I know angles A and B. So technically, I could do 180 minus 60 minus 60 to find the missing one. But if two are 60, the third one has to be 60 as well. So all of my angles are equal, which therefore means all of my sides are equal. So all of these sides have to be equal. On 12, I'm told that every single one of my sides are equal with those tick marks, which means every single one of my angles are equal. And in a triangle, if all three are equal, it's going to be 60 degrees. The math behind that, the triangle is 180. I have three angles that are all equal, so divide by 3, and that's going to give you that 60 degrees. All right, in 13, we have an X and we have a Y. So we can start kind of pretty much anywhere. If we notice where our X's are all on the sides of our triangle. It's on PQ, QR, QR, and PR. Well, it says it's equilateral. Equilateral means sides are equal, all of them. So I know that all of these are going to equal each other. So I can pick my two favorite because an equation needs two parts. So pick your two favorite to work with. You cannot use all three. It's not like it tells you all three sides are going to add up to equal measure. No, it just tells you all sides are equal. Pick your two favorite because an equation needs two parts. So I'm going to pick PR and RQ. 11y minus 23 equals 9y plus 4. And minus 9y. 2y minus 23 equals 1. And add 23. 2y equals 24. Last step, divide by 2. So y is 11. And then again, if all of your sides are equal, that means all of your angles are equal. So technically, I can do two things. I can put 7x minus 3 plus 7x minus 3 plus 7x minus 3 equals 180. Because I know all my sides are equal. So, all my angles are equal. So my 7x minus 3 can be in every single angle. That's a lot. I also know that if all of my sides are equal and all of my angles are equal, if all my angles are equal, each angle is going to be 60 degrees. So I like it better to just do 7x minus 3 equals 60 degrees. And 3 over 7x equals 63, 5 by 7, so x is equal to 9. You'll just have to remember that equilateral means equal angular, and if it's equal angular, every angle is 60 degrees regardless.